So today we are going to study the strains in the in the case of thick cylinder, and this concept is quite simple compared to the one that we studied in the case of thin cylinder. We will directly use the stress value to calculate the change in dimension of these thick cylinders. For example, the first thing is uh, change in diameter, and over here it has been mentioned as well. And we also discussed in the case of thin cylinders that the hoop stresses or due to which hoop strain is being produced, and due to these particular strain the change in diameters occurs. So if I want to figure out that how much change in diameter has occurred in the case of thin cylinder when all the stresses are acting on this one, I have to use these hoop stresses and this hoop strain. And if I want to represent this change, that will be change in diameter over original diameter. This will be my strain in the case of thick cylinder. But obviously, since we know from the concepts of physics that when this hoop strain will occur, or due to this the hoop stresses might occur, then this hoop strain will be less than the actual strain, and how much it will be less, that will be given by this particular equation, that our hoop strain or actual hoop strain which will be acting will be less by Poisson ratio times the strains that are acting in the perpendicular direction. So if I write the actual equation for hoop strain, that will be hoop strain minus mu longitudinal strain minus nu into radial strain. Now, the only difference between this equation and the equation for thin cylinder is that in that case, we would ignore this radial strain because its magnitude was very small compared to the other two strains. Now, the remaining two parameters, if I write these strains in terms of stresses, that will be 1 over E sigma h minus this one will be nu into sigma L minus this one will be nu into sigma R. And since I told you that hoop strain is change in diameter over original diameter, so we will have this change over here. And if I further simplify this one, I will get this equation for change in diameter. Now, in the previous class, we did derive the relationship for the hoop stress, for the longitudinal stress, as well as for this radial stresses. And we derived we know how to calculate these three parameters based on the pressure, based on the radius, internal radius or outer radius. So once we have these three parameters, we can directly substitute them into this equation to get the change in diameter in the case of uh, thick cylinder. And same is the case with change in length. For change in length, obviously the longitudinal strain or this longitudinal strain will be causing or responsible for change in length. And again, if I represent this change in length, that will be length time epsilon L. And we know that this strain in longitudinal stress will be less than the actual value, and the actual equation will be epsilon L minus nu into epsilon H minus nu into epsilon R into length. Now, if I write this equation in terms of stresses, that will be this equation. And in this equation, again, the parameters, we know how to calculate them and by using our formulation, and we simply have to substitute the values into this equation to figure out the change in length when all the stresses are acting on the cylindrical element. So this was a brief discussion about the strength. And in the case of cylindrical element, we are only going to focus on these two dimensions, the change in diameter and the change in length. And I will simply, and these all these stresses we have already derived, and let's solve one numerical question to get the idea about the application of this particular formulation that we have just derived. And just for your information, I have already uploaded this assignment related to these cylindrical element. And now after today's class, you will be able to solve all the questions in that assignment. So I expect you to submit that on time. Just let me switch on to the whiteboard. Can you see the screen now?
No, sir.
Okay, I believe it's visible to all now. So we have this cylindrical element for which we have been provided with an external diameter of 300 millimeter and the internal diameter of 200 millimeter. And we have been told that this cylindrical element is subjected to a pressure of 20 megapascal. So if I write the parameters, this external diameter is equal to, let's call it as DE, equals to 300 millimeter, and the internal diameter is 200 millimeter. And the fluid internally, now in the case of thin cylinders, usually we would be provided with only the internal fluid. But as we did our derivation, I explained to you at that point as well that there are two kinds of pressures which can occur onto this thick cylinder. One can be from external forces and the other one for the from the internal forces. So in this question also we have been provided with both the internal fluid pressure as well as the external fluid pressure. So the internal pressure Pi is given as 20 megapascal and the external pressure or outer pressure is given, let's call this as O as well, as 5 megapascal. And we have to figure out the maximum hoop stress developed, and also we need to plot the variation of hoop stress across the thickness. So first thing obviously the hoop stress is, and the second thing that we need to figure out is the radial stress. So if you remember, we did derive one relationship for the calculation of hoop stress, that was A plus B over R square. And for radial stress, we had the correlation as A minus B over R square. So can anyone tell me how can I figure out these parameters A and B? Anyone?
सर इसकी इक्वेशन थी सर वो यूज कर दो
कौन सी इक्वेशन?
सर जो हमने डिराइव किया था ए और बी का जो इक्वेशन थी
एक तो हमने इक्वेशन डिराइव किया था, दूसरा लेट्स सपोज मेरे पास इक्वेशन नहीं है अभी, ठीक है, मैंने इन्हीं से यूज करके निकालनी है. आई विल टेल यू द रीजन लेटर कि मैं क्यों इनको यूज कर रहा हूँ. तो मैं इधर से ए और बी कैलकुलेट कैसे करूँगा? We did
सर
this.
बाउंड्री कंडीशन यूज कर सकते हैं.
I will have to apply the boundary condition. So let's say my first condition is that at internal diameter or at diameter equals to 200 mm or internal radius, how much will be the radius? Obviously that will be half of this one. So at Ri is equal to 100 meter. What is my radial stress? Can anyone tell me?
सर माइनस बी इंटरनल होगा प्रेशर जो इंटरनल.
So that will be equal to opposite of this internal pressure which is given to me. So I know that at internal radius, the radial stresses is equal to 20 megapascal. So this is my one condition. Now if I substitute this condition into this equation, I will get one equation, that is minus 20 is equal to a minus b over 100 square. So this is my one boundary condition. But again, I need another condition as well. Now from the question, I know that at a radius of, or outer radius of, how much is that? I believe it is 300 millimeter is the diameter. So the outer radius will be 150 mm, and my radial stress will be equal to the outer pressure, but it should have a opposite sign. So that is minus 5 megapascal. Now if I substitute this equation into this one, I will get another equation, that is minus 5 equals to a minus b over, the outer diameter is 150 square. Now, if you remember, we did have one direct correlation, but some students were asking on that day as well, sir, do we need to remember that one or memorize that one? Even if you don't memorize this one, you can memorize these two equations, and for every question, you can apply the boundary condition to get the values of A and B directly in numerical terms. Once you have these values of A and B, you can back substitute into these two equations to get the values of hoop stresses. So now can anyone tell me what are these two parameters A and B? Take 2 minutes and calculate the values of this A and B. Khizar,
यस सर.
क्या आंसर आ रहा है?
सर अभी मैं कैलकुलेट कर रहा हूँ.
354. What is the answer of A and B? As you in the class.
सर ये 9.61 समथिंग आता है ए की वैल्यू.
9.61. I think we need to recheck.
माइनस
सर
6.3.
7 आ रहा है सर.
How much?
7 सर ए की वैल्यू.
A is 7. And what about B now?
सर 2.7
2.27.
I think it is something 27123, right? So these are the two variables or the two constants from our original equations. Now, if I substitute these constants back into this equation, I will have two separate equations for the calculation of hoop stresses and for the radial stresses. So the hoop stress is 7 plus 270 123 divided by r square, and for the radial stress my equation will be 7 minus 270 123 divided by r square. So these are my two stresses. Now, what should I substitute over here to get the hoop stress? Anyone? ये रेडियस की वैल्यू कितनी सब्स्टिट्यूट करेंगे?
सर ये तो कुछ भी हो सकता है, मतलब जिस रेडियस पे हम फाइंड करना चाह रहे हैं.
So as we discussed in our initial classes about this topic, if this is the cylindrical element, and we knew from our equation that these hoop stresses vary based on the thickness or radius of the cylinder. For example, let's suppose if I substitute this value of radius, then I will have one value of hoop stress from this equation. Then I can take another point over here along the thickness. Then I will get another value of this hoop stresses. And similarly, at this starting point, I may get a different value of this hoop stresses. And same is the case for this radial stress. So these stresses do vary based on the radius of the or thickness of this cylindrical element. And this was asked in the question that you need to plot the variation of hoop stresses and radial stresses across the thickness and show at least 4 points. So what does that mean? That means that we have to calculate different values along this thickness. For example, we know that the outer radius is 150 mm and the inner radius is 100 mm. So we can take two these points and some points in between these 2 points or random points in between this one. For example, I can take one as 120 mm, then I can calculate this hoop stress at a distance of, let's say, 135 mm and so on, and I will calculate the values of these hoop stresses. And once I have these values, I will plot these along the thickness to show the variation with the change in thickness. So if I calculate the hoop stress in this case, let's say first I will calculate at a radius of 100 mm. So at r is equal to 100 mm, give me the value of hoop stress and radial stress.
hoop stress 34 आता है.
So the hoop stress will come out to be 34. Just check. Yeah, it is 34 megapascal. And what about the radial stress?
minus 20.
Radial stress will come out to be minus 20 megapascal. So let's calculate another value at a radius of 120 mm.
इसका रेडियल
25.75.
25.575
रेडियल
megapascal. How much is the radial stress?
minus 11.75.
Minus or plus? Can you?
Minus है sir. minus 11.7.
Okay, so it comes out to be minus 11.75. And at a radius of 135 mm, what is hoop stress?
21.81.
The hoop stress will be 21.81. And what about radial stress?
Minus 7.81.
Minus 7.81. And let's calculate the fourth value at external diameter. So what is hoop stress now?
Nineteen, sir.
So the
19.
stress will come out to be 19 megapascal. And what about radial stress?
Minus 5.
That will be minus 5 megapascal. So now we have 4 points that were asked in the question. And if I want to show the variation along the thickness, I can simply plot just like we plot the shear forces or bending moment diagram. I can simply plot over here these 4 points. For example, if I first plot the variation of hoop stresses uh, along this thickness, I know that at external diameter, my hoop stress is this 19 megapascal. So this point will be 19, then I have 21, then I have 25, and final point is 34. Now if I combine all these points, I will get this kind of parabolic variation for the hoop stresses. And this point we also, let me just plot it in the opposite direction. And this point we also discussed while doing the derivation that these stresses vary in the parabolic manner along the thickness. And over here, we have done the proof of this thing as well. So at internal diameter, it is 34 and at external, it is 19. And in the same way, if I plot the variation of radial stresses. So for radial stresses, I know that at internal diameter, the stress is minus 20. So this will be minus 20, and then it continues to decrease. So at external diameter, and then it will be minus 11, then it will be 7, and the final value is 5 megapascal. So this will be the variation of radial stresses along the thickness. The max value is minus 20 and this value is minus 5. So I have just plotted the opposite direction of arrows just to differentiate between the positive and negative sign. And another thing which you can notice from here that even by using this equation, I have got the same value of radial stresses at external and internal diameter, and these values are equal to minus P naught or minus Pi. And in the same way, I've got the values at intermediate points between these two diameters. So this is how you have to plot the variation of these stresses and radial stresses along the thickness. Any question about this example? So if there are no questions, then we can move on to another example, which is related to the calculation of change in diameters. So this is a statement. It has been mentioned in this question. We have been provided with these parameters. We know that it has been asked that the hoop and radial stresses at the inner edge of the shell are 81.8 and 40 megapascal in compression, and the internal diameter of the cylinder is 180 mm, and the length of the cylinder is also given to us. The longitudinal stress is 21.93, and what we have to calculate is change in internal diameter and change in length. So, and by the way, this term over here is not mu, it is nu actually. So you can just make this correction. So if I write the parameters, the hoof stress is 81 megapascal and the radial stress is minus 40 megapascal and the longitudinal stress is 21.93 megapascal. The original length or internal diameter that is given to us is 180 mm and the original length is 1.5 meters, or I can write it as how much will it be in millimeters? 1500 millimeters, right? And the value of E is given to us as 200 gigapascal and nu is 0 0.3. Now, just now we derived two relationships for the calculation of change in diameter and change in length based on these stresses. So if I again just copy those one over here, so these are the correlations for the calculation of change in diameter and change in length. Now, first thing obviously that we have to do in this question is to calculate this change in diameter. So if I do that, the equation is this one: change in diameters equals to 1 over E sigma h minus nu sigma L minus nu sigma R into 2 times radius, or I can say that it is equal to internal diameter itself. So I have all the values. If I substitute into this equation, 200 into 1000, sigma h is 81 minus nu sigma L is 21.93 minus, and this will change into positive sign because over here we have the stress as negative. So this will be 0 0.3 plus 0 0.3 into 40, and internal diameter is 180 millimeters. So over here I have multiplied with 1000 because E was given to us in gigapascal units and all these stresses were in megapascal unit. So just to be consistent with the dimensions, I have substituted over here this 1000. So what is the change in diameter now?
Zero point zero seven.
Well, change in diameter comes out to be 0.0785 mm because this internal diameter was also in millimeters unit. So this is about change in internal diameter, and in this question it was asked that uh, the internal diameter is 180 mm. So this obviously is the change in internal diameter. If you have been given the values of the external diameter, then in that case you have to use the stresses of external edge. So you know that these stresses vary based on the radius. So in that case, maybe you will be provided with external stresses, or maybe the enough information will be provided to calculate the external stresses. So just be careful about these small variations. Now, in the same way, if I calculate the change in length, that will be 1 over E sigma L minus nu sigma H minus nu sigma R into length. The length was given to us as 1500 mm. This whole thing will remain the same, and over here we will have 200 into 100. Now give me the change in length.
सर ये 1 ओवर ई में 200 मल्टीप्लाई बाय 1000 है या 100 है? जीरो में से
क्या होना चाहिए?
1000 होना चाहिए। जीरो 0.64 से
0.6.
0.648 मेरे हिसाब से ये आ रहा है।
And can anyone else also check this one?
सर ये लॉन्गिट्यूडल स्ट्रेस जो है वो 21.93, आपने 81 लगाई है इक्वेशन।
I didn't understand. क्या कहा आपने?
सर ये हूप स्ट्रेस की जगह आपने लॉन्गिट्यूडल स्ट्रेस को लेकर और लॉन्गिट्यूडल स्ट्रेस की जगह हूप स्ट्रेस को लेकर
Sorry, yeah, I mean, okay, yes. There is one correction. So the longitudinal stress was 21.93 and the hoop stress was 81. So now calculate this value.
जीरो 0.0722
So the change in length will come out to be 0.072 mm. Now just be careful about the unit conversion in this question. For example, this I have substituted in millimeter unit because I knew all these values are Newton per millimeter square. I remember last time around students are reporting the change in length as 7.2 meters just because of the fact that they didn't make the correct conversion. So just be careful about this unit conversion, and from the answer you will also get an idea that this much change in length is not possible in the case of cylindrical. Obviously the change is very small and they are usually in the units of millimeter. So today I am going to conclude my lecture at this point, and this is all about the cylinders. We have studied the stresses and strains both in the cases of thin cylinders and thick cylinders. I have uploaded the assignment, so try to solve that. And in the next class, we will start with a new topic, which is uh, columns, and after that, we will be left with the last topic, that is curved beams. So we are left with these two topics, and in the next week, probably I will upload the lecture videos for theories of failure. I told you before that we will stick to a recorded lecture for that one. And last time around, I also did the recorded lecture because that is basically a theoretical concept, and it will be wise decision to not have a live session because it gets too boring. But again, I encourage you to to watch that whole videos, and if you have any question, then you may ask me about that one. So this is it about today's lecture. We will meet tomorrow again at 10:30 inshallah for our MOS class. So till then, Allah Hafiz and take care.